Hello, am I audible to all of you? Am I audible to all of you? Hello. All right, that's great. Okay, so I hope there were some mic issues. Okay, but it's sorted right now. All right, so coming back, so we are basically going to discuss the limits, continuity, and differentiability, and this is the part three of the previous continuing sessions. Okay. All right. So what I was basically talking about is that along with your preparation, whatever your notes, whatever lecture notes, and whatever question bank you're basically following, it is also very important to have a NCRT and the NCRT exemplar, especially for JEE mains preparations. Okay, because there are two advantages having it, right? The first advantage is that you also get prepared for your board examination, right? And along with the JEE mains, you're basically preparing both the things simultaneously. So it is a cherry on a top, right? So you got to prepare both the things simultaneously with one particular effort, right? So that being said very much, so let's get started on this part three. Now, before I start, there is a good news for all of you that we are going to start up live batches on our platform, and the live batches you can contact for more information about the live batches on this particular number that is given on the screen. Okay, so in case you want to know more about the content, you can contact on this particular number that is mentioned over here. Okay, so please contact on this particular number to get personalized doubt clearance, anything regarding any questions or regarding your JEE preparation and how you should basically attempt for your JEE paper as well. Okay, this you can contact on this number to get connected with me and my team. And in case you want a personalized tuition, like one-to-one tuition, where you're basically not able to study in a group tuition and you want personalized care or attention, you can always contact us on this number. In order to know more about the schedule of the batches and what are the how we basically take the classes over here and what are the upcoming lectures and how we basically go on planning the sessions, please contact on this particular number over here. Okay, that being said, pretty much let's continue our today's session. All right, so let us start discussing the important parameters that I think that you should also know regarding differentiation before we actually start our topic of differentiability, right? So we are going to discuss some questions regarding differentiability in today's class, but it is also very important because sometimes you will see the questions are also coming from methods of differentiation, right? So we are basically going to discuss the methods of differentiation, especially in our concepts. Now, before we start to understand what are the method of differentiation, it is very important to know that when a function is differentiable, right? A particular function is differentiable when we have the continuity of its derivative, right? Now, again, the question is coming like how we get the derivative. So, in order to find the derivative, it is very important to know or how the derivative of a function is basically found out. Right. You must have studied that whenever we basically talk about differentiability, we basically try to figure out that what is the criteria to talk about the differentiability, right? So generally I've seen the criteria like LHD or left hand derivative should be equal to the right hand derivative, and that's the most important criteria for a function to be differentiable, right? Now, now, before we talk about the differentiability thing, and also along with that, now once you know the differentiability of a particular function, it is also very important to know how you can differentiate and get the results. Okay, so I am writing the differentiation. Okay, so for example, if you want to differentiate any function at any particular given point x such that the function is continuous within that particular domain location. Okay, it is continuous in its own domain. Okay, now this is given by, this simply given by limit you takes this x. So let us use some, or maybe we can use the same notation. Let us say I'm interested to find out the derivative at x equals to 1. Okay, so I will tend our x towards x1, and then I'll try to find the f of x minus f of x1 divided by x minus x1. So I will try to find this particular limit, and this limit is basically going to give me the result of the first derivative. So first derivative is basically, or the derivative of function, or the first derivative of function is nothing but it is a slope of the tangent, right? Initially so if you look at this particular result over here, it basically gives you a feel that this is basically the, this is nothing but this particular ratio denotes the slope of a chord. Okay, or maybe we can talk about slope of a line, right? Now when this particular chord is made such that this x1 or this point x tends towards this point x1, in that case, when the point x tends towards x1, in that case, this chord actually becomes a tangent to any curve. So let's say I have a curve like this, any arbitrary curve, and let's say our point A is over here and point B is over here, right? So if I take up any arbitrary point, let us say B is my arbitrary point and A is my known point, let's say x1, and B is my arbitrary point x, right? And the corresponding value, so my point B will be given as x comma f of x, and my point A will be given as x1 comma f of x1, right? So if I try to find out what is the slope of this line AB, the slope of the line AB, it will give me the result as f of x minus f of x1 divided by x minus x1, right? Now what if I ask you the question that what if I tend this point and bring it as close as to B point? So if I bring this point A as close as possible to this point B, then it is almost like this, then this x1 is very close to x, right? So in this case, this chord is basically like a tangent. It's basically like a tangent at the point A. At the point A, it is basically like a tangent. So this chord will transform into a tangent. So chord is basically getting transformed to a tangent, right? So therefore, this, when we put the limit or when we limit this x towards x1, then it's basically nothing but it is a slope of the tangent, right? And in other ways, or you can have studied in physics that basically the first derivative denotes the slope of the tangent, right? So it is the slope of the tangent over here, right? So derivative is nothing but it is a slope of the tangent, right? Now there are different, so this is a geometrical implication of how we calculate the derivative, right? But after we learn this particular definition, we don't need to actually calculate the limit every time when we calculate, right? When we calculate our derivative. So what we are going to do is that we remember certain formulas that will actually help us in order to solve our questions quickly, right? So, and in order to solve those formulas also, sometimes the formula becomes very tedious to solve easily, right? So therefore, we try to introduce some other ways that is called as parameterization. We try to express our x and y in terms of some parameters so that our differentiation becomes much easier. So let's say I give a simple example to illustrate what I was basically talking about. So let's say whenever I see a function like square root of a square minus x square, looking at this particular function, it will give me, so if I ask you to derive or differentiate this particular function, it will be very difficult because you have to go on doing the differentiation, but not that difficult, but you have to use the chain rule, right? But if you don't want to use the chain rule and you want to get a quicker solution, the better method to basically look into over here is that we can take use of some parameters. Parameters means you can consider parameter as something like, if I considered a particular variable in terms of another variable so that I can vary that particular variable to get to the entire variable of that given variable, right? So let's say I take a simple example, and let's say I take a simple example of circle, right? So any point on a circle can be represented in terms of x comma y, right? And we know the circle will have a radius. Let's say the same thing can also be written in terms of radius and this angle theta. So what I can do is that I can also represent x as r times of cos theta and y as r times of sin theta. Now what is the advantage of doing this? That in place of two parameters or two unknowns, that is x and y, I'm able to replace these two unknowns in terms of only one parameter, that is theta, because r will be known for a given circle. So instead of writing x and y, I can tell you the point P can also be given in terms of theta, right? So that is the biggest advantage that we basically try to do when we are talking about parameterization, right? So these are the some of the important substitution, and if you know the trigonometry, then if you know that if I put in place of x as a cos theta or a sin theta, then this particular square root term will get simplified easily as a cos theta or a sin theta, depending on whichever trigonometric angle ratios you are basically putting in, right? Similarly, if you have substitution like square root of x square plus a square, it is advisable to put substitution like a x is equal to a tan theta or a cot theta. Now, so on. And if we have substitution functions like square root of x square minus a square, it is basically advisable to put substitution like x equal to a sec theta or a cosec theta. Similarly, now these are the three trivial one, and these are something that is also very important. Sometimes the questions are also being asked from this particular part as well, right? So it is very important to know these concepts as well. Like for example, if you have square root of a minus x by a plus x, then it is said that then it is basically advisable to put x equals to a cos 2 theta. Similarly, if you have square root of a square minus x square by a square plus x square should be equal to a square cos 2 theta. If you have square root of ax minus x square, then x would be a sine square theta, right? And if you have square root of x upon a plus x, the x would be a tan square theta. And if you have square root of x minus x, then your x would be a sine square theta. If you have square root of x minus a into x minus b, your x would be a cos sec square theta minus b tan square theta. And if you have a square root of x minus a into a b minus x, then your x should be a cos square theta plus b sine square theta. Right. So these are all these set of substitutions that you need to recall before we actually set out to solve some questions. Okay. And why I'm talking about this parameter is that now sometimes when you do implicit functions derivation or derivative of an implicit function, it is sometimes difficult to take a note of all the terms and perform the differentiation at a one go. So it is always advisable, if you can change or transform your two variables into one variable problem, then it is very advisable to do so, right? And it is very easy to do differentiate in terms of parameter as well. So you differentiate x with respect to this parameter theta, and then you differentiate y with respect to parameter theta, and then if you perform the dy by dx, right? So so this is all about the substitution part, and something also very important, that is methods of differentiation, right? So if we have differentiation of implicit function, let's say, and implicit function, like if we are not able to separate, and if I have a function equation like which is basically containing x and y and is equals to 0, so this kind of function are basically called as implicit function. The best method to basically differentiate is basically if you go on differentiating with respect y with respect to x, right? And so collect the terms containing dy by dx on one side and the terms not involving dy by dx on the other side, and then express dy by dx as a function of x and y both. That's the simplest way. But if you want to get the quicker solution of implicit function differentiation, you can always go with it by taking this minus negative of partial differentiation of x with respect to partial differentiation of f with respect to x divided by partial differentiation of f with respect to y. Okay, so what you're going to do is that if you have this expression, first of all, partially differentiate this expression with respect to x, and then partially differentiate this particular expression with respect to y, and the ratio of this will give you the result of dy by dx. Okay, so this is a shortcut method that you can also take in mind in case you are going to solve some questions, okay, on where basically it involves implicit derivations. Okay, is that clear to all of you? Please let me know, is this part clear to all of you? So today's session we are basically going to discuss theory, as well as we are also going to solve some questions as well, right? Now this session is going to be really useful, especially for JEE mains, right? Because in JEE mains I've seen there are a lot of questions where the only just differentiation questions are being asked, and students generally make mistakes by doing the question in a hurry. Okay, so please don't make that silly kind of mistakes that you hurry up for the solution and you get anywhere mistaken, and then you get lose 5 marks. Okay, so instead of gaining that 4 marks easily, you basically end up giving 1 marks extra to the IIT examination, right, or the JEE examination, right? So you're not losing 1 marks, you're basically losing 5 marks. Okay, so that is basically your opportunity, right? All right, so with that part, let's move to the next topic, right? And next we basically try to give you some examples like how we basically use this particular concept in our use case, right? So let's say I will take a simple example. Now sometimes also very important to also have an understanding that we are also going to use the logarithm, right? Now how do we understand that we have to use log into our functions while we going to differentiate, right? So sometimes it is very much seen that you have a function like you have an exponential function, like let's say I have an exponential function y is equal to f of x whole to the power g of x. Now whenever you have a complicated function with and the power of the another complicated function, it is always advisable if you can go with log, right? And also the second hint that can trigger to your mind while to take a log is that whenever you have the results like the derivative of the function divided by the same function, then this basically gives you the implication that it is coming from the differentiation of log of that particular function, right? So whenever you have this log, then only this kind of expression will come up. So it is kind of a hint that will give you that you have to take log and proceed with the question. Okay, so That being said, pretty much, and whenever you also see a functions like a function in a fraction, like you have a multiple functions and then multiple and divided by another multiple sets of functions, so it's always advisable to go again and take the log and work out with the following results, right? So please take a recall on these two cases. This is very, very important, right? Amazing. So the working rule is to take the logarithm of the function, and the second one is to differentiate the function. Now another important set of differentiation sometimes basically come up is the infinite series, right? So it says that if we have an unknown variable y, which is basically given in the form of an infinite series of x, and we have to find out the dy by dx of that particular term. So what we do is that we try to remove one or more term, and that basically do not affect the series because it is already an infinite series. So what we are trying to do, we are trying to find out the pattern in the infinite series, and we are going to replace that particular pattern with the known unknown variable, right? So what if I give a simple example, like if you have y is equal to square root of f of x plus square root of f of x plus square root of f of x and so on. So what if I say that these are the same repeating terms? So if I neglect one term, then it does not affect the series. So what I can do is that I can write this expression similar as y is equal to square root of f of x plus y. And in this case, I am able to express y square is equal to f of x plus y. And then if I do the differentiation, and then I will get the result. So instead of carrying out this infinite series, I am able to easily find the derivative of that particular series, right? Is this part clear to all of you? All right. So please let me know in the live chat. Veer Singh, hi. Hi Veer Singh. How are you doing, Veer Singh? I hope this particular concept is basically clear to all of you. Okay. So please let me know in case you have any doubt. Okay. I will try to help you out as much as possible. Okay. Please look into the concepts and also try to understand. Okay. And in case you're someone who is watching the session after the live class is over, you can always put your questions in the comment section. Okay. So please put your questions in the comment section as well. I will be very happy to answer your lovely doubts. Okay. But please don't let doubts accumulate in your mind. Okay. All right. So that's being said pretty much. Now let's move to the concept of differentiation of a function with respect to another function. Now this is something that's a very simple thing that we use the parameters for, right? So I'm not going to discuss this much in detail because you already know it, that when we express a particular function in terms of another variable, and the x and y in terms of another variable, then we have to individually differentiate it, and then we have to perform the following fraction in order to get to the derivative, right? So please take a note of this. Now let us come to the most important thing that is basically going to come in an examination, and it is a most trivial question, I would say. Okay, that generally comes in JEE mains, advanced, and any other examination you can consider. Okay, that is the differentiation of any integral function. So that being said, this is very, very important. So let's say that we have two functions g1 of x and g2 of x, and both of them are defined on closed interval a to b and are differentiable at each point on the open interval a to b. And f of t is a continuous function, and it is also the value of f of t is basically bounded between, and the value of f of t is bounded between g1 of a to g2 of b, right? So that being said, if you need to differentiate this integral function f of t dt with the variable integral limits going from g1 of x to g2 of x. Okay, so the result is very, very simple. You just need to put, so I'm writing the result over here because the result is very simple. So when you differentiate this, you just need to put f of the upper limit, that is f of g2 of x, and then differentiate this g2 function with respect to x minus f of lower limit of x g1 of x, and then multiplied with the derivative of the lower limit. Okay, so if you calculate this particular expression, you're basically going to get the differentiation result of the integral function. I hope this part is clear to all of you, right? Now this is very, very important because if you look at any previous year questions of JEE mains and advanced, you will definitely notice that these questions are generally come up in the chapter of limits, in the chapter of area under the curves, okay, and even in the chapters of differential equation. These kinds of questions come up very frequently. So it is very, very important to have this idea how we go on differentiating the integral functions. Okay, if you look, if you do any analysis of previous year question, you will find out that there are lots of questions just focusing on this particular topic. So that being said, it is a very, very, very crucial topic. Okay, is this part clear to all of you? Is this part clear to all of you? Right? Is this part clear to all of you? Please let me know in the live chat. I'm basically going through a live chat, and please let me know if you have any questions. Okay, I will try to help you out as much as I can. Okay, and we also know that the JEE advanced result is out. So it's basically a good luck for all of you who basically have qualified all of the examination. Okay, and congratulations, very, very congratulations for all the students who basically qualified the examination and who have also achieved very wonderful ranks. Okay, don't forget to stay tuned live on the important discussion that how you are going to now comes the most important decision of your life, that after your JEE advanced results are out, you basically have to sit for the JOSA counseling, right? So now comes the most important and tedious job, that is basically to figure out how you are going to decide on which college and which branch you should go for. So don't forget to check out our videos on JOSA counseling on this particular platform. And also I'm going to come live on this particular platform, and we are going to discuss what are the multiple options that you can explore in the different JOSA counseling, right? Based on your given rank and given situation. It may be also possible that you haven't qualified JEE Advanced, but you have already cleared JEE Mains with a good rank. In that case, you are eligible for NITs as well, right? So NITs and GIFTF, like the government funded institutes, okay, and all those triple ITs, we are basically going to talk about those things in detail in the live session that I'm going to conduct after this sessions. Okay, so please stay tuned for the live sessions that we're basically going to have it on our channel. And also I have published a video on JOSA counseling on this particular platform, so please stay tuned on that particular video. And if you think that this particular session is going to help up many students, please share this video with your friends, with your relatives, and with anyone whom you think that this content is going to create a impact. Okay, so that being said, thank you, and let's continue. Okay, so let's move to the next part. And before we start to discuss about the important JEE Mains question, I wanted to discuss something that no one actually discuss in many of the lectures, is that how we differentiate a determinant. Okay, now let's say I start with a very simple thing, that if we have a is a 2 by 2 matrix and we have a determinant of that. Okay, we have a determinant of a 2 by 2 matrix, and I want to know that what is the derivative of that particular determinant. So if I know the 2 by if I have given any determinant, the differentiation is basically carried out in two ways. Either I can go by column or either I can go by rows, right? So here I have taken the example where I'm basically going, first of all, whenever you have a determinant, okay, after you have the determinant, if you have to find the derivative of the determinant with respect to x, you can go by finding out, first of all, the derivative of the first row or first column. But make sure that whenever you are differentiating with respect to row or with respect to column, you're sticking to only one particular thing. It's not like you're first differentiating with respect to column and then you're with the row and then you're doing with the column. That is exactly wrong. Okay, so make sure that you first of all differentiate with respect to the row, and then in the second time also differentiate with the next row. Okay, or if you are starting with differentiation with the column, then with the first column, and then you go to the differentiation of the second column. Okay, that's how you should proceed. So over here you can see that when I'm differentiating it, so if I'm differentiating with respect to the row, so first of all I will differentiate the first row, okay, and keep the second row as it is, and take the determinant of this particular thing plus determinant of the first row as it is, the first row as it is, and the differentiation of the second row. Okay, so that being said, this is how we basically figure out or find the differentiation of the determinant. Okay, so please take this in mind, because this is going to be very, very important, and you can get to see this in very soon. Okay, so we have a question with us. This question is basically from the previous year JEE Mains question, and this has been a question which has been a lot of difficulties for the students who basically don't know how to differentiate the determinant. So it is very, very important to have this idea before we start to solve this question. So over here we can see that there is a function, that is y of x, which is defined as the following determinant, right? So y of x is defined as the following determinant over here, and for all x belongs to real number. It is said that then find out that second derivative of y with respect to x plus y, right? That is what is basically asked to find out in this problem over here. So if I go on differentiating this function with respect to x for the first time, I will go on differentiating with the rows, right? Because if you look at the other two rows, they are all constant. So in other two cases, the differentiation of that is going to yield you the result as 0. So it is, so the result is going to be like differentiation of the first row. It will be like cos x minus of sin x, then cos x minus of sin x, and then we will have as it is 27, 28, and then 27, then 1, 1, and 1, and the other twos are going to be zeros and zeros, because if you are going to differentiate with respect to constant, it is going to be 0, and whenever in a determinant we have any particular row or column all zeros, then the determinant also is 0, right? Then again if we differentiate this particular result, again the result is going to be like minus of sin x, minus of sin x, then we have minus of cos x, and over here we will have minus of sin x minus of cos x, right? And then this will be 27, 28, 27, 1, 1, 1, and the rest two are again going to be zeros and 0. So the second derivative is going to look like this, right? Now here what we can do is that we can take this negative sign common out of the determinant, okay? So because the first, from the first row we can take the minus 1 as common, we can take out of this determinant, right? So over here, now another way to do this question is also like we can find out that what is our function by solving this determinant over here. We can find out this and then we can go on differentiating it, and we can find the result as well. So if you try to find out this result, so this second derivative is going to come out as, the second derivative is going to come out simply as, so minus of sin x times sorry, 1 plus cos x times of, plus cos x times of 0, and then we'll have minus sin x plus cos x into, again we will have minus of 1, right? So that is going to be the result of the second derivative, and then if we add it again with y, so in this case I have to calculate y. So if I calculate y, you will figure out that this particular result, that y that is going to come out as, so if you just calculate y, so I can go into the next page. So if you just calculate determinant of y, the y is going to come out as, the y is going to come out simply as sin x into 1 minus cos x into 0 plus sin x plus cos x, and then we'll have plus of 1 whole multiplied with minus of 1, right? So if I simplify this expression, it is going to come out as minus of cos x minus of 1, right? So therefore the second derivative of this determinant plus of y is going to come out as, simply as minus of 1, right? So if you just do this calculation, you are going to get the result as minus of 1. Now here in this question, maybe if you don't know the differentiation result of the determinant, you will be still be waved off, because ultimately you have to find out y also, right? So because you ultimately have to find the y, but in case it is a difficult determinant and you don't have to find the y, you just have to find the first derivative and then put the values of x to get the derivative result, then this particular approach is going to be the only helpful solution over here. Because otherwise if you go on calculating determinant and find the determinant and then you go on to expand those expression and then you find out, it's going to cost you a lot of time, right? And sometimes it might also happen that you make some silly mistakes and you may actually go wrong, right? So please make sure that you know this particular result, because it's going to be very handy sometimes in different kinds of questions. Okay, so this is one of the JEE mains question that I felt that it is very important to know the concept, and with this the answer to this question is going to be option number C. Okay, sorry, it's going to be option number C. Okay, so option number C, that is minus of 1, is going to be the correct answer. I hope this solution is clear to all of you. Is this part clear to all of you? Is this solution clear to all of you? Please let me know if this solution is clear or not. Please let me know this solution is clear or not. Okay. So please try to understand the guiding principle behind how we basically try to do this step-by-step calculations. Okay. So in case if you have any doubt in any of the steps, in any of the particular timestamp of the video, you can always comment in the description, in the comment section with the particular timestamp, and I will try to answer to your query with that particular confusion. Okay. So make sure you do take the best advantage of this live lectures and also this free contents over YouTube, right? So, and in case you know someone who is basically badly in need of this content, you can definitely share these videos among your friends, your relatives, and anyone whom you think that they are basically going to need this video for their upcoming preparation. And if you're in class 11th and class 12 and you're planning to start learning from any online tuition, you can also consider joining our own online batches. Okay. The best advantage of joining our batches is that you get personalized one-to-one attentions. Okay. So in case you want to take one-to-one live classes, you are basically free to go with our one subscription. Okay. So that being said, very much, we are basically going to move to the next problems. So now I'm going to start up solving some more important problems of the JEE Mains. Okay. So these kinds of questions are very much favorable for JEE Mains because I have seen these kinds of questions basically come up, and students generally have no clue on how to proceed and to find the answers. Okay, sometimes this expression looks very like implicit and very non-linear for all of people, and sometimes it becomes not very easy to solve. Right? Okay, I should not say it non-linear, but yeah, sometimes it becomes difficult for people to basically get to the derivative of these kinds of implicit solutions. So how we proceed with this is very important to follow the steps and try to understand how we basically go on, so that whenever you are having this particular problem in the examination, you are able to do it. Okay. Now, if you look at the problem over here, what I can see is that I can see one particular thing as common, that is basically like f of 2x plus y, f of 2x plus y, and f of 2x plus y, and then we have f of 2x minus y, sorry, 2x minus 2y, and then we have 2x minus 2y. These things are common, but the sign is different, right? So what if I do take one important thing is that if I take f of 2x plus 2y divided by sine of x plus y, sine of x plus y is equal to some constant. Now why I'm doing it, you will get to know it very soon. What if what I'm doing is basically trying to club the parts. What I'm doing is that I'm trying to club the part. Okay, I'm trying to club the part of f of 2x plus 2y. So if I try to club the part of f of 2x plus 2y, it is going to be like sine x cos y, then we have minus cos x sine y. So it is nothing but, it is, this particular thing is nothing but sine of x minus y, and which is equals to, so if I have f of 2x minus 2y, and then if I take a common, then this is going to be like sine of x plus y. So if you just try to club this part, it is going to be sine x cos y plus cos x sine y, which is nothing but sine of x plus y, right? Then if I take this part in the denominator, because here what you can see, if you take 2 as common, so it is x plus y, and if you take 2 as common, it is x minus y. So you can see this x plus y and x plus y over here, so that makes a common, and that gives me the idea to take this part as some constant k, and then I can also write it as f of 2x minus 2y as equals divided by sine of x minus y as some constant k. Let us say this is we assume. Okay, now why I'm doing it, you will get to know very soon, right? So what is the advantage of doing is that we are basically able to write our function, that is f of 2x plus 2y as equals to some constant times sine of x plus y, sine of x plus y, right? Now if in this particular situation, if I put y is equal to 0, because I have to see the derivative of this function f at x equal to 0, right? So if I look at over here at x equal to 0, or if I have f dash of 0 over here, and if I put y equal to 0, I have the value of f dash of 0 as half, and if I put y is equal to 0, then I am able to simplify this particular result in terms of only one variable, that is I'm going to get the result as f of 2x is equals to some constant times sine of x, right? Now after we have this result, if I put again x equal to 0, then k will come at 0, right? So what we are going to do over here is that, so from this particular result again, and also one more thing to be noted is that f of 2x minus 2y is equals to some constant times sine of x minus y, right? So if I have this particular result, So from this particular result, if I change from 2x to x only, and again I'm putting also here also y is equal to 0. So this is the same result, and then if I put in replace x with x by 2, then I'm going to get the result of f of x as k times of sine of x by 2, sine of x by 2, right? Now, what I'm doing is that I'm trying to get the result that what is the value of my k, what is the value of my k, right? So if I from here, if I differentiate this result, this is going to come out as k by 2 times of cos of x by 2. Now over here, if I put x equal to 0, if I put also x equal to 0, then I will get the value of f dash of 0, which is equals to k by 2, and in the result it is given as is equals to half. So from this result we are going to get the value of k as equals to 1. We are going to get the value of k as equals to 1. So this simplifies our result much further, and we are going to get f of x as simply as sine of x by 2, sine of x by 2. So therefore the derivative of x is going to be like half times of cos of x by 2, half times of cos of x by 2. And if I find the second derivative of this particular function, it is going to be like minus of 1 by 4 sine of x by 2, right? And therefore we need to calculate what is the value of 24 times of second derivative of f at 5 pi by 3. So if I put that, so 24 times of f double dash of 5 pi by 3, this result is going to come out as, so if you put it over 5 pi by 3 over here, so it is going to be 5 pi by 6, and then 24 times of it is going to be coming out simply as minus of 3. It is going to simply come out as minus of 3. So with this part, we are going to get the result to this question as again as option number C. Okay, so minus 3 is going to be the correct answer. Please let me know if you are getting the same answer or not. Please do let me know if you are getting the same answer or not. Are you all getting the same answer? So minus 3 is going to be the right answer over here. I hope this solution is clear to all of you, right? So today's session was mostly about important concept about the methods of differentiation and some of the important underlying questions that can be framed in the chapters of methods of differentiation. Now I have some more questions left as a homework to all of you to make you also try those questions and try to get the solution of it. Okay, so here are the first homework problem that I want all of you to please try to solve this problem and let me know the answers in the comment section. Okay, please let me know the answer key of this particular problem and as well as the solution. Okay, as well as the solution, I mean how did you try to solve this question. Okay, and this is my second homework problem, and this is very important because these kinds of problems you can find out many in the previous year questions as well. Okay, so if you look in the previous year question, these kinds of question has been asked a lot of times, where you are given a particular relation of a function between x and y, and then you find out a difficult kind of derivative where to differentiate again and again, and you go on and put in the results. Okay, so the easiest way to solve it is basically when you are deriving it, it's smartly you're putting the values of y as well. Okay, so if you are, how well are you able to do this, let's see. So based on this, I would like to all of you to please try this problem and let me know the answer in the comment section. Okay, as well as the solution you're basically getting and how you are getting the solution. Okay, so I'm very happy to know your answers as well as to help you out with the way you should go about solving these questions. Okay, so that being said pretty much about it, so let us conclude our session over here. So we are also going to come up live in the upcoming sessions where we're basically going to discuss for the JEE main sessions, where we're going to take up the new topic of application derivative. Okay, so and also we are going to solve lots of previous year questions so that you also get a taste on how we have to prepare for the upcoming JEE mains examination. Okay, so that being said pretty much of it, let's conclude our session over here, and thank you everyone for your attention. And so I hope you are able to use this content as much as you can. Okay, and please try to take the best use of this content because it's going to be really gold mine for all of you people, because just by preparing with this particular content you can definitely clear your JEE mains. Okay, yeah, hello once, how are you doing? You're very late once. Okay, so here we go and we conclude our session. Thank you for everyone for your live attention. All right, so keep preparing and